Hi, this is presentation of our paper to be presented in CVPR 2025. It's titled Camouflage Anything, Learning to Hide Using Controlled Out Painting and Representation Engineering. In this slide, we present our contributions. Our work makes several key contributions in field of camouflage generation and visual understanding. Firstly, we apply controlled out painting and representation engineering that we abbreviate as CO plus RE to create realistic camouflage images. Also, secondly, we introduce CAMOTI, a innovative evaluation metric addressing the limitations of traditional metrics like FID and KID. And lastly, what we do is we perform LoRa-based fine-tuning on bireferent baseline, which is a method to segment camouflage images and enhance the segmentation quality for generic camouflage scenarios. We are motivated to work on shortcomings of the state-of-the-art method, A-grade. State-of-the-art method, as you can see, has missing textures in the background. Sometimes the object looks salient and the background is distorted. We want to improve on these as highlighted in A, B, and C in this image. This slide is about the motivation of CAMOTI metric. Traditional metrics like FID and KID penalize highly camouflaged generation as the reference distribution might differ from the generated distribution even if the generated samples are of high quality. We want a metric that can measure the degree of camouflage. Hence we propose our CAMOTI metric that should be high for highly camouflaged images and low for non-camouflaged images. In this slide, we present the architecture of Camouflage Anything, the pipeline of our camouflaged image generation framework. Our framework mainly includes three steps: designing a control image given the foreground and the background mask that you can see as C in the main figure. The representation module that you see in the right hand side bottom, that is used to generate contrastive conditional representation to be fed to stable diffusion unit decoder and encoder using cross attention. And lastly, we have our control outpainting module that we term as CO module, which accepts control image and modulates SD encoder and decoder modules to generate camouflaged images. In this slide, we present control design in Camouflage Anything. During training, we set the mean background color in the control image to match the color of the background object that you can see in C. During inference, what we do is we take the mean background color and fill it so that it matches the color of the foreground. This way, the generated images during inference is much more camouflaged. In this slide, we present the representation engineering module. What we do is we find a contrastive representation, what we call as contrastive vector, and apply cross attention with the actual representation. And then we find an updated vector that is used to update the representation. More details can be found in next slide and in the main paper. This slide presents the mathematical formulation of our representation engineering module. So we find the contrastive vector, then we perform a cross attention with the actual representation, and then we find the update vector. And we use alpha is equal to 1 as the update value that we have found empirically that maximize the performance. In this slide, we give mathematical details of CAMOTI metric, where we expand CAMOTI to camouflaged optimal transfer metric. So we have given the illustration of chemometric, where we construct two Gaussian mixture models for foreground and background and compute the optimal transport distance between them. We use Weisstein distance, mainly the second Weisstein distance, denoted by W2 between two Gaussian mixture models. Once we get a distance, we normalize the measure by applying a sigmoid transformation. And then what we do is we scale the values between 0 and 1. The chemometric is high for highly camouflaged images and low for low camouflaged images. In this slide, what we do is we show the comparative results of our method with the other methods that we have used for benchmarking. So we can see that using the previous methods, the results are not so good, but using our method, the results are of higher quality. Particularly if we compare with Lake Red, which was previous state of the art from CVPR 2024, we are making it slightly better, and the background details are much more pronounced in our method. For quantitative performance benchmarking, we use FID and KID for assessing the generated images. We find that our method has the best FID and KID numbers. The lower the FID and KID, it's better. So as you can see that we have highlighted in bold our results, which is better than previous state of the arts, including image blending and image inprinting methods. In this slide, we perform the ablative study, that is a qualitative ablative study of our methods, that is using the control design that we propose, that is filling the background with the foreground's color during inference, and also the representation engineering module. We can notice that with plus BG control, that is filling the background with the foreground's color, the images tend to have similar foreground and background color in the generated images. We also find that when we add the RE module, that it enables creation of high quality textures in the background. In addition to previous qualitative ablative study, we have also done ablation study using quantitative methods, that is using FID and KID, as well as our method that we proposed, the chemometric. We see that using our analysis that CO plus RE plus BG configuration demonstrates higher FID and KID metric in conjunction with strong chemote scores. So we deem CO plus RE plus BG to be the optimal selection for generating high quality camouflaged images. In this slide, we show the application of camouflage anything to enhance segmentation in generic camouflage scenarios. In this figure, we perform a comparison of BiRefnet on general camouflage image with and with LoRa fine-tuned. With LoRa tuning, cases of missing segmentation and partial segmentation is solved for general objects not in standard datasets, and the numbers that you see in the table reflect our observation. To conclude, our camouflage anything presents an approach for generating camouflage datasets using controlled outpainting and representation engineering. Our method not only improves the quality of camouflaged images but also introduces CamoT, a novel metric enhancing evaluation alongside traditional metrics. Experiment results validate the effectiveness of our approach, showing significant improvements in image generation and segmentation accuracy for camouflage generic and salient objects, thus setting a new benchmark in the field. Overall, our contribution paved way for future research in camouflage image generation and segmentation, offering new methodologies and evaluation metric that can be further explored and refined in subsequent studies.